What's up, all stars? I've got a nice physical sciences discrete set for you today. In question 1, we're told that CH3 is this free radical species that's metastable and a colorless gas. Free radicals, react with things in a chain reaction until they meet another free radical and get neutralized. We're told it's metastable, so we don't maybe know exactly what that means, but maybe it can carry out more normal reactions than most free radicals could. 25% of 2 moles of it will react with water to form the organic solvent methanol and elemental hydrogen, totaling a pressure of 1.2 torr. What value is closest to the partial pressure of the formed elemental hydrogen? The only MCAT relevant detail we need to know here is that for calculating pressures, we should be focusing on the gaseous species and kind of ignoring the other ones. Also, we want to be familiar with Dalton's law of partial pressures, where if we could calculate mole fraction of formed elemental hydrogen, that will equal pressure fraction. Quick scan of the answer selections shows that all the answers are in units of pressure, and all are a fraction of the whole, which makes sense because only part of the CH3 reacts, and that should be exerting some portion of the pressure. The final thing to execute is to use this nifty mnemonic, "Have no fear of ironclad brigadier." In their elemental form, hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine are all diatomic gases. So let's balance this equation working backwards from that fact. Then we form this organic solvent methanol, which we should be able to infer has an alcohol and a methyl. Then we've got this water species. Shouldn't be a plus, this should be an arrow. And then that reacts, of course, with this methyl. I like to balance things carbon, hydrogen, oxygen in that order. I've got carbon balanced already. Then hydrogens, I've got 3 plus 2 is 5 here. 3 plus 1 is 4, plus 2 is 6 here. So trying to maybe multiply this by 5 and this by 6 could get really complicated. So what I'm going to do is take a step back to carbon, and let's multiply each of these carbons by 2. So I know the carbons are balanced, and then let's see if we have more favorable math. So now I have 6 hydrogens plus 2 is 8. Here I have 6 plus 2 is 8 plus 2 is 10. So I just need 2 more hydrogens on the left side, which I can do by multiplying this by 2. Now I have 4 plus 6 is 10, and that matches the right side. From there, I want to calculate the amount of moles that would form of H2, and then from that, I can calculate pressure fraction. So if I start with 2 moles here, and 25% of that reacts, that means that 0.5 reacts. And based on the balanced equation here, we should be able to form 1/2 the moles that we started with of CH3 into elemental hydrogen. So 0.5 should end up being 0.25 hydrogen. Then to get the fraction, we should do 0.25 divided by the whole, which will be the remaining 1.5 plus this 0.25, or 1.75. So this should be easy enough because 25 goes into 1 4 times and then into 0.75 7 times. So this should just be 1 over 7. Then 7 into 1. That gives me a value of about 0.4. For the MCAT, we can stop there, especially because we have this qualifier, what is the closest? So we're not looking for the exact answer, just looking for the closest thing to 1.4, which is clearly answer selection A, 0.15 torr. Question 2 states, upon analysis, a compound was found to contain 6 grams of carbon, 1 gram of hydrogen, and 8 grams of oxygen. What is the empirical formula for this compound? Not a whole lot to assess for this as long as we know how to calculate empirical formula. But we can maybe take a look at the answer selections, and we can see that we're coupled with two sets of two that are maybe a double of each other. So if we were thinking to go for molecular formula, we could go for C or D. So if we had to take a strategic guess and we were short on time, you can maybe select A or B. So what we want to do here is we want to write out the molecular weight of carbon. And this you would be able to get from the periodic table that you have on your MCAT. And then it's 12 grams per mole. Then hydrogen is going to have a formula of 1 gram per mole, and oxygen would have 16 grams per mole. At that point, then we kind of align 6, 1, and 8 here. We want to multiply these up to be an even fraction of these. So we want to multiply these by 2, and that should give us a value of 12, 2, and 16. Then we divide the gram values divided by the gram per mole values, and that should give us a value of 1 carbon. 2 divided by 1 is 2 hydrogens. 16 divided by 16 is 1. So we set a ratio of 1 carbon to 2 hydrogens to 1 oxygen. And that clearly aligns to answer selection A. So take a look at question 3. The fundamental resonant wavelength of a pipe open at one end and closed at the other, that is 2 meters long and 0.2 meters in diameter, is what? So we'll need to draw this or recall what the formula for fundamental wavelength is for a pipe with one end closed. Then maybe recognize that the 0.2 meters in the question statement is irrelevant here because we only need length of pipe. And then we'll apply what we have. So let's draw this out. So if we have a pipe closed on one end, the smallest resonant frequency we can have is just like a fourth of a wave with a node at the end. So if that's a fourth of the wavelength, then the wavelength would be 4L. Okay? At that point, L is 2. 4 times 2 is 8. That should be clearly answer selection B. Question 4 states, sound is a compression-decompression mechanical wave that requires a medium. As the sound wave travels, it transports what? So we want to recognize it's a general physics fundamental fact that waves carry energy. But we are told that this is a mechanical wave. So would that, for instance, transport the medium that it is within? Okay. We need to think what that means. It even gives us the clue compression, decompression. It just means the air molecules are going through a phase of compression and then decompression, compression, decompression. But they're not actually being moved. Okay. So we can match to an answer selection that has just energy and not mass being moved, and that should be answer selection